So we're going to turn off the stopper here. That's good. And let's go ahead and add the Eugenol distillate here into the separatory funnel. That's good. Now we're going to extract this 3 times with methylene chloride. So what that means is we're going to add the methylene chloride in. You can use the funnel still. There we go. And Jen's going to go ahead and do the extraction here. And you'll notice her technique. She holds the flask with her thumb, the stopper there, with her forefinger, and then she shakes. Alright, so we've got Jen doing the extraction now. Continue to shake, and then she's going to release the pressure. Alright, so this is the first extraction. Okay, I think that's probably good enough. We're not hearing anything in the pressure release. Let's go ahead and stick it into the ring. We're going to separate this out here. We're going to just take off the bottom layer here. Of course, she's going to take the stopper off the top. And there we go. And she's going to leave the water in there. Just leave a little bit of methylene chloride in the, there we go, in the separatory funnel. That's perfect. Alright, let's go ahead and do the methylene chloride again. So what we're trying to do here is just extract as much of the eugenol and the acetyl eugenol out of that water, that top layer, as we possibly can. And that's why we're doing this extraction 3 times. It's good. Alright, nice. Okay, we're going to do again one more extraction of methylene chloride. Good. Okay, that'll do it. In reality, most of it probably goes in on that first extraction, but you know, it's always good to do a couple more to try and get as much of the material out as possible. So now at this point, what we're finding is that the eugenol and the acetyl eugenol are now in the bottom layer, the layer that Jen's putting into this beaker here. That's good enough, that's fine. Alright, so now we can discard that top layer. We're not interested in it anymore. So why don't we put that into a waste beaker. You can pour it out through the top, Jan. Okay, let's rinse that out with a little bit of water as well. Just to clean up a little bit before we do the next part of the extraction. That's good. That'll be fine. Now let's pour that into the waste. Good enough. Alright, stick that back in. Now we're going to put the extract, these 3 layers of methylene chloride we just did, those are going to go back into the separatory funnel. And we're going to do an extraction now with sodium hydroxide, right? Okay, so we're going to extract twice with sodium hydroxide. So we're going to put in how much?
At 10 mLs.
3 times. Oh, actually 3 times. Okay, let's do it. So 10 mLs 3 times. So she's putting 10 mils there. You'll notice we do have 2 layers, and that's fine. Going to do a bit of a shake here. Okay, Now what's going on here is that the eugenol now is going into the top layer, which is the aqueous layer, as I'm calling the aqueous layer. And the bottom layer is what I'm calling the organic layer. And that contains the acetyl eugenol. So the eugenol is a little bit acidic, so it's gone into the sodium hydroxide layer. So what I want you to do, Jan, is take out the bottom layer. We do have to keep it. Take out the bottom layer. And you'll notice she's taking it out into a beaker that's labelled O, which is great for organic. And she's going to leave the top layer in there for now. So she's going to get it as close to the interface as she can there. Alright, now she's going to take that top layer and pour it into another flask, one labelled A. And this is for aqueous. So she's going to go ahead and empty that one. That's good. Okay. Alright, turn that off. Let's put the bottom layer back in. Now what we're trying to do here is extract as much of the eugenol out of the acetyl eugenol mixture. The eugenol is going into that top layer. So she's going to add another portion now of sodium hydroxide. She's going to extract. We'll do the same thing. We're going to let that settle a little bit. Make sure we get those two layers. And as you can see, this can take a little time to separate. So you want that nice, yeah, it's not quite separated yet, Jan. I see a kind of like that little third-ish layer there. You need to wait for that bubbling to kind of dissipate before we can separate that out. So it can take a little bit of patience here to go ahead and do that. Okay, it looks like it's getting there. Let's go ahead and take out that bottom layer. Yeah, it looks like it did separate. That's good. So she's taking off that bottom layer. That goes in the O beaker for organic. She'll take it down to pretty close to the interface. Okay, that'll do. And now you can add that's in the top layer to the previous top layer that we added. There we go. That's aqueous. It's good. Okay, and we're going to do this one more time. Okay, so add another portion of the sodium hydroxide. Shake it up a little bit. And again, notice how she holds it upwards and then makes sure that there's no release of pressure anymore. And then we wait for that to separate out. Well, it looks like it's separated. That's good. Alright, let's go ahead and release that bottom layer. So at this point, you have a bottom layer that's about 30 mils, because that was how much methylene chloride we added initially. And then we'll have a sodium hydroxide layer, or an aqueous layer, that's also about 30 mils, because we did 3 extractions with sodium hydroxide. Because now we're going to go ahead and add that top layer again to the other top layers that we had. So put that off to the side. Yeah, one thing you'll notice, the first extraction is probably going to be yellowish, and then the other 2 will probably be fairly colourless. That's alright. So could you put those side by side over here? So what we've got on the left here is the aqueous layer, which consists of sodium hydroxide, and it consists also of eugenol. The organic layer consists of methylene chloride and consists mainly of acetyl-eugenol. So we're going to dry this organic layer here with magnesium sulfate. We can either use magnesium sulfate or anhydrous sodium sulfate. Either one will be fine. They do have to be anhydrous though. So let's go ahead and add some magnesium sulfate, just some that's on the end of a spatula there. That's a good amount. Okay, we're going to give it a bit of a stir. And the idea is that the magnesium sulfate will stick to the bottom as long as there's water present. Now if it doesn't stick to the bottom, then you've probably added enough. So it looks like we've gone ahead and added enough there, because I can see, go ahead and stir it a bit more please, Cassidy, so you can see it all coming around there we go. See, it's not all stuck. If it was all stuck, then we'd have to add more magnesium sulfate. Alright, so I'd like you to let that settle for a second, and we will let that settle out, and then we'll do the next step. So what we're going to do now is, now that we've given this a chance to settle, we're going to pour the magnesium sulfate, so we're going to pour the solution of the magnesium sulfate into the flask, but we're going to make sure we decant, which means we want to leave the solid in the actual beaker. So that's what we're going to do. So slowly, 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 we're just going to pour. And try and leave the solid in that beaker. Alright, so we're going to go ahead and rinse the remaining magnesium sulfate there with some methylene chloride, about 10 mils, and again we're just going to decant. Okay, it's good. Alright, now we're going to take this over and do the rotary evaporator. So we're going to evaporate this organic layer now using the rotary evaporator. And go ahead, Jen, and clip the flask. And she's going to hold on to the flask as well until the vacuum takes. And she's put that head clip on there as well. I showed you how to use those earlier. Alright, go ahead and turn on the vacuum, please. You turn on the vacuum pump over there. And now she's turning on this switch here, 90 degrees towards you. Alright, the vacuum's on, that's good. Now you can turn on the spinner. Thank you. And then take it down into the water. Now the thing is that this is where the acetyl-eugenol is. It's in here somewhere. And the acetyl-eugenol itself is actually a liquid, or it's a very, very low melting solid, but it's probably going to come out to be a liquid here. So what's going to happen is you're going to take this and evaporate it down, and at the end it's going to look like there's nothing there. That's why it's important to have made sure that this flask was weighed first. And I know that these ladies did that. And what's going to happen is once we evaporate this down and it looks like nothing, that will be the end of it. There will of course be something in there, and that will be the acetyl-eugenol, but there won't be a whole lot of it. So I wouldn't expect huge gobs of product here. The acetyl-eugenol doesn't make up a very large percent of clothes at all. So we're going to do that until it looks like it's completely run dry, but it really hasn't. In fact, it's getting to that point right now. Alright, so as you can see here, it looks like there's nothing left, but there is actually a band of product that's around the middle of the flask there. So now that we've got that, and it looks like all the liquid's pretty much gone, we're going to go ahead and take that off, and we will reverse the process. So take it up, turn off the spinner, turn off the switch here. There we go, 90 degrees down, and then turn off the vacuum. You notice she held on to the flask while the vacuum was off. That was good. Now we can remove that flask, I hope. There we go, that's good. And let's take a look at what we have in there. So as you can see, there's a little bit of stuff in there, but not very much. And then we'll weigh that flask, we'll be able to calculate the amount that we have in here. So we're going to now acidify this aqueous layer because it now is sodium hydroxide with the eugenol in it, but eugenol is in an anionic state. So we want to add the concentrated HCl to that now and see if we can bring it out of solution. Now what's going to happen is that we're going to use the acid dropping bottle here, and you can see that Jen is going to move it so that the nub is in line with the dropping part. Could you just point at the dropping part, please? Yeah, best that part. That's the part where it drops. And there's a little channel it has to go through. Now she's going to put her finger on top of that, and now she's going to add it to the solution that we have. Now what's going to happen is this solution is currently clear and it has no precipitate or anything in it. What's going to happen is that we're going to add this acid, and it's going to turn a lot cloudier as the eugenol comes out of solution. Eugenol is actually water insoluble. So let's go ahead and stir that, please. Yeah, continue to add the acid. And don't stop until you see that solution become completely cloudy and stay cloudy even after you stir it. Do you see it becoming cloudy at all?
Mm-hmm. Yes.
Hopefully you all can see that on the shot as well. Good. So she's going to continue doing that. There's no point in testing for litmus until the solution is completely cloudy, because that's the only sign you have that the eugenol is actually coming out of solution. It could be a fair amount of acid you have to add as well, so just continue to do that. How are we looking, Jen?
It's still kind of clearing once we stir, so.
Okay, stop it for a second. Let's have a look at what the solution looks like. Yeah, you can see it is clouding up a bit, but it still needs a bit more. Alright, so now she's been adding it, and you can see that the solution's become cloudy. She's now going to test it for litmus. And the way she's going to do that is she's going to take a little bit out and put it onto a piece of litmus paper that's on a watch glass. We don't put litmus paper directly in. You can see the litmus paper's turned red, which is excellent. That means it's acidic, and we can go on to the next step. So we've got the eugenol here. It's been acidified. As you can see, it's quite cloudy because it's been acidified. That means that the eugenol is actually sitting around in the water. It's not very soluble in the water. So we're going to go ahead and pour that into the separatory funnel. And we're actually going to extract it 3 times with methylene chloride, which means that the methylene chloride is going to be what will take in the eugenol. Let's go ahead and add in 8 mils of methylene chloride, and that'll be on the bottom layer. And this is where the eugenol is going to go. So again, we're just doing the same extraction technique. Probably just one more time. Yeah, it's not very much action here, so let's go ahead and put that in. Now we're interested in taking out this bottom layer. We want to keep that bottom layer, making sure that it is indeed completely separated at this point, which it looks like it is, right? So she's got a separate beaker there for that bottom layer. Good. Now she's going to add another 8 ml portion of methylene chloride. And she's going to extract it again. Yeah, most of the eugenol probably goes in on the first extraction. But again, we'll... Yeah, it's probably good enough. As long as you're not hearing anything, it's probably done. Alright, that's good. So we're just going to take out that bottom layer. We're going to leave the top layer in there. Remember, we're trying to extract as much eugenol as we can out of that top layer. Okay, good. And let's add the third portion. That's good. Sounds like that's good too. Alright. Take out that third layer. Sorry, that third extraction. So we've got the magnesium sulfate here. We're going to dry off this bottom, this eugenol layer. It's got the methylene chloride and eugenol in it. So she's going to put a bit of magnesium sulfate in there. We're going to give it a bit of a stir around. Let's go ahead and put the lid back on the magnesium sulfate in between, okay? Just in case. It does suck in the water, so we try and keep it. I'm looking at that, and are you seeing that it's there's stuff floating around here?
Yeah.
Yeah, that's good. So it's not all stuck to the bottom. Mm-hmm. That means you've added enough, and we can go ahead and decant that. Sometimes you might need to wait a little while for it to settle out. It depends. This looks like it's pretty much settling on the bottom, so that's good. So she's just pouring it in there, and she's going to try and leave the solid in the beaker there. Okay, that's good. Now we're going to add 10 mils of methylene chloride to that just to rinse it off. And we're going to decant that in as well. Now this flask has been weighed because we're going to evaporate it now. Alright, so we're back over here at the rotary evaporator. This is the eugenol fraction that we're going to end up evaporating. So let's go ahead and stick it on, please, Jan. Using the cat clip again. She's holding on to that while she turns on the vacuum, and she turns on the vacuum here as well, 90 degrees towards her. Turns on the spinner and then lowers it into the water. Okay, so that's the part that she turns to turn the vacuum on. You can see it's turned towards her right now. When she turns it off, she'll turn it downwards 90 degrees. Now this is just like the other one, and what we're going to do is we're just going to wait for this level of liquid to go down to it looks like nothing, but there will actually be eugenol in here. So we're going to let that sit for a bit, and then we'll come back to that in a second. So now you can see that the liquid's pretty much gone here, and it's just this band of liquid that appears to be going around the centre, and that's our signal that we can take this off now. Now what she's going to do, she's going to lift it up out of the water. Alright, she's going to turn off the spinner. Turn the switch here 90 degrees downwards, and then turn off the vacuum. And we can remove the flask. We'll take a look at what's in there. Now, this flask was weighed, so now they'll know exactly how much eugenol is in here once they reweigh that flask. I'll wipe it off first, and there it is. There's eugenol on the bottom there.